All right, number 10 is an optimization question. A rancher wants to fence in a rectangular area along a river and divide it into 3 equal-sized pens with fencing that runs perpendicular to the water. He is not going to build a fence along the river. So the river is going to provide one of the boundary edges for this rectangular area. So we've got a river, and then he's going to fence in some rectangular area along this, only using fencing for the 3 sides. And then he wants to divide this into 3 pens with fencing perpendicular to the river. So let's let the depth be y here and the length across be y. He's got 120 feet of fencing available. What is the most land that he can enclose? So what are we optimizing? And what is our constraint? Okay, so we want to maximize the area. So the area in terms of x and y is just the area of this rectangle, which is just x times y. Our constraint is that we only have 120 feet of fencing. All right, well, how much fencing are we using? We're using 1, 2, 3, 4 pieces of fence with length x, and then only 1 piece of fence of length y because we're not building a fence along the river. Okay, so once you've got what you're optimizing and your constraint, solve your constraint for one of the variables. Now the easiest variable here to solve for is y, so I'm just going to subtract 4x over to the other side, and then this gets substituted into the y in the function that we're optimizing. So we are going to be optimizing area, which is x times 120 minus 4x. You could leave it like this, but we're going to be taking the derivative, and right now we'd have to use the product rule, so we might as well go ahead and distribute the x. So we get that the area is 120x minus 4x squared. Now before we find the max here, let's state the domain. We know that x has to be greater than, actually even just greater than, technically greater than 0 if you want any area at all. But I mean, he could actually, I guess, use all 120 feet on y. It just would have no height to it, and it would be right along the river, and your area would be 0. Now there's an upper bound for x as well, and it's not 120 because if he builds one edge of 120, he's got no fence left for the other pieces. So the way you find the upper boundary for the x is that y also has to be greater than 0. Well, y is the same thing as 120 minus 4x. So we solved this inequality and we found the upper bound on x. Add 4x over to the other side and divide both sides by 4. And the upper bound for x is 30. Okay, so now we need the max here, so let's take the derivative. That's 120 minus 8x, set it equal to 0, and that's going to give us a critical number. If we add 8x over to the other side and divide both sides by 8, that's going to give a critical number of 15. Now we're actually going to check that it's a max. There's a couple of different ways that you could do this. If you use the first derivative test, you just need to make a sign chart here. Let's see, can't be any bigger than 0. It can be any less than 0, any bigger than 30. If you plug in 1 into the derivative, 120 minus 8 is positive. If you plug in 20, 120 minus 160 is negative. So since the first derivative is positive and negative, it means the function is increasing and decreasing, so it's a max. Another thing that you could do, I'm going to shift this up. Hopefully it'll stay focused. Or you could use the second derivative test. Second derivative is negative 8, which is less than 0 always, no matter what x is. If the second derivative is always negative, it means that the function is always concave down. So if you find a critical number, it has to be a max. Either of those verify that we have indeed found the maximum. All right, and then the last step is to make sure that we actually answer the question that's been asked. So it says, what is the most land that he can enclose? So we're actually being asked for the area. Well, the max area happens when x is 15, so take 15 and plug it back into the area function. Find a of 15. So that's 120 times 15 minus 4 times 15 squared, and that gives us 900. The units of area, square feet. Most he can enclose with 120 feet of fence is 900 square feet.